Gears are another kind of simple machine that are incredibly popular in engineering systems. And they're very popular because they have a very large efficiency, something like 80 to 90%, as well as being able to provide a lot of different reasons as to why we should use them. So some of the reasons are they increase or decrease torque from input to output, increase or decrease speed, and also change the direction of rotation. Now, typically, gears are not used if you are trying to transmit motion over long distances. For something like that, the belt and pulley would be a better choice, or a chain and a sprocket arrangement. But for smaller distances between input and output, the gears are very good choices. So there are various kinds of gears out there. The simplest kind is called a spur gear. So this is a picture of a spur gear. And spur gears are created from cylindrical blanks. So you have cylindrical blank like these, okay, and you cut teeth on them. And these teeth are cut parallel, okay. So these teeth are all parallel to the axis. So you can see these over here. This is, let me choose, okay, this is fine. This is the one teeth, this is another teeth, and they're all parallel to the axis of rotation, okay. So we have a smaller gear here. This is called pinion, that's the term, and this one is called gear. So the bigger gear is generally called gear. They're all gears, but for the smaller gear we use the term called pinion. So as you can see in this case, if this rotates in the clockwise direction, then this is going to rotate in counterclockwise direction. So if let's say you wanted to transmit the motion from here, let's say this being the input shaft, to this one, to let's say there was another gear here. Let me choose another color maybe. Let me pick okay, so let's say there was another gear over here, okay, and I have the teeth cut over here. Then I could transmit the motion from this being the input to this being the output by employing 3 gears like this. Now we'll see later on as to how do we analyze what the speed ratios would be, what the torque ratios would be, and so on. But you will see that the spur gears are very popular and very common among the gearing systems. In fact, you will get a couple of these in your snappy axle kit as well. Now, if you take one of these 2 gears, either the pinion or the larger gear, let's say the larger gear over here, and make it to be of infinite radius, then what is going to happen to this gear? Essentially, it's going to turn to a straight line like you see over here, okay? So this gear is called a rack. It's called a rack, and this is pinion because this is clearly the smaller gear. So this is called a rack and pinion gear system. Now, what would this be useful for? So you can clearly see that if this is the axis of rotation, this is rotating with some angle of speed, then this is going to have only a linear speed. So this would be useful for converting a rotary motion into a linear motion. So no longer rotary to rotary, but rotary to linear motion. And again, the teeth over here are also cut parallel to the thickness. A third kind of gear is called bevel gear. Bevel gear. Now, bevel gears basically allow you to transfer the motion from one axis to another axis where the other axis is perpendicular to the one axis. So in this case, here is my input axis of rotation, okay? And then this is my other axis of rotation. And these 2 axes of rotations are at 90 degrees from each other. The other thing you would notice with this particular gear system is that the teeth over here are actually at an angle. They are forming some sort of helix. And the advantage of a helix kind of angle as opposed to a straight cut angle is that there is a gradual contact between the teeth, and that gives rise to smoother and less noisy operation, which in turn increases the torque carrying capabilities of these kinds of gearing system. You can see the same kind of teeth in a 4th kind of gear over here, okay. You can see the same kind of teeth cut over here. They're at an angle, they're not straight. Now the basic difference between the bevel gear, spur gear versus what you're seeing in this picture over here is that these are called helical gears. So both of these are helical gears, and essentially you have a helix cut on the blank, and you can see that the axis of rotation, so this is the axis of rotation for this gear, and this is the axis of rotation for the other gear. Clearly these two axes are non-intersecting. In fact, all three of them are non-intersecting. They don't intersect at any point, and they're offset from each other. So they're parallel, but they're offset from each other. So this gives rise to very interesting kind of motions if you can use them. And once again, helical gears, because of the way their teeth are cut, they give rise to smoother and less noisy operation, and as a result they have more torque carrying capabilities. Now if you take one of the helical gears where you have all these teeth and convert them into just one teeth, okay, so just one teeth, so this is one single teeth that is wrapping around on the blank, then this becomes what we call a worm gear arrangement. So worm gear arrangement, this is called the worm because it looks like a worm, and this is called a gear. A worm gear arrangement actually gives rise to very large speed or torque ratios. So whenever you're looking for large speed and torque ratios, you should use a worm gear. But one of the problems with the worm gear is that they are not as efficient as other gearing systems are because of the profile of the teeth cut over here. Now we do require the profile of the teeth to be cut in a certain way so that we have certain fundamental properties satisfied. So one of the requirement is that the profile of the teeth should be involute. Now what's an involute profile? Well, involute profile is often if you take, let's say, a cylindrical disc and you wrap let me use another color. If you wrap a cord all around it, okay, and while keeping it taut or in tension, you begin to unravel. Let's say this is the end point. You begin to unravel it, okay, so you keep it taut, so this is always going to be tangent, okay, and you begin to unravel it, and as you're unraveling you can see that more and more length will open up, and if you join all these points, then this profile is called an involute. It's called an involute profile. Now the advantage of using an involute profile for a gear is, so all these are involute profiles. So let me draw this a little bit bigger. So here's my gear blank, and this is my one of my tooth, okay. So this profile over here, this is a straight section, this profile over here, this and this is called an involute profile. Advantage of involute profile is that when you have two gears meshing with each other and the teeth on both the gears are of involute profile, then if the input gear rotates at constant speed, then we are guaranteed that the output gear will also rotate at constant speed, okay. So if I have my pinion and I have my gear, so pinion being my smaller gear and gear being my larger gear, if this is rotating with, let's say, some constant angular speed omega 0, then this is going to rotate with some constant angular speed omega 1, and that is guaranteed only if the teeth are of involute profile geometry. Okay, so that kind of tells you that if you didn't know anything about involute profile, you might be tempted to just cut a gear with maybe something like this, where these are straight lines, or something like this, where it's basically like a square or a rectangle, or you could try to do something even more funky, something like this, and expect the gears to work. Now of course, if you engage it with another gear with a similar kind of teeth profile, they will rotate, but there is no guarantee that if this rotates with constant speed, then your output is also going to rotate with constant speed. That will almost never happen, okay.